Okay, so it says, what is the length of the arc of the circle with the measure of a central angle is 60 degrees and the diameter of the circle is 8 centimeters? So I'm just going to draw myself a quick little picture here. So we have our circle. It says the diameter, you got to pay attention to radius versus diameter. The diameter of the circle is 8 centimeters. So what's it asking us to find? The length of the arc, right? Length of the arc. So length of an arc is the formula S is equal to radius times theta, where theta is in radians. So pi over 180 is how you get it to radians, if it's not already in radians. Because we want the physical length of the arc. Okay? So it says with the measure of a central angle is 60 degrees. So we're trying to find the arc of a 60-degree central angle. So we're trying to find the physical length of that arc. So we'll do our radius, which is, be careful, what's our radius? 4. So S is equal to our radius, which is 4 centimeters, and then times theta, which is 60 degrees. Now, if we were to calculate this right here, we get an answer in degrees. That's why we change it to radians, so we get a physical length. So we'll also multiply by pi over 180. Let's just do it all in one. That way, it's a little bit easier. So less steps, the better. Type it in, go. Type it into your calculator. 4 times 60 divided by 180. And then we always change it back to a fraction. So you got 4 pi thirds, I heard. That's right. 4, then 5 on top, right? If we multiply straight across, there's like a 1 under these. That's why it's 4 pi thirds. And that's centimeters, right? Everybody? And if we wanted to know the actual length, we would do 4 pi divided by 3, hit enter. Just keep that in mind, but we'll just leave it in terms of pi. Questions? You'll see a length of an arc problem on your final, most likely. Okay, it says, what is the area of the circle with radius 2? What's the formula for area of a full circle? Pi r squared. Guys, you've got to know that for your ACT. You've got to know that for this class. What's circumference's formula? We did it yesterday. What's circumference's formula of a circle?
Pi r squared divided by 180.
You're not quite. You're on the right track. What is it?
Pi r squared.
No, you guys just said the area of a circle is pi r squared. What's the circumference of a circle, guys? 2 pi r. Circumference of a circle, guys. 2 pi times the radius. Right? That is just the full circle. Circumference is finding the outside distance of the circle, right? 2 pi is radius times, this is the radius times theta. It's just theta's already in radians for you. 360 degrees in radians is 2 pi. Does everybody understand that? We did that just yesterday, guys. Remember that. You need to know that for your ACTs or you're gonna bomb an easy problem. Okay, area of a circle with a radius of 2. So, we're doing area of the full circle, pi times 2 squared, right? So, area is pi times 4, right? So, area is 4 pi. If I said find the circumference, I didn't, but let's do that too, just for practice. We would do the physical, so that would be filling in the full circle, right? Filling in the area, guys, right? And then circumference would be finding the physical distance of just the outside of the circle. So we do 2 pi times 2, so that came out to be 4 pi, which they just happen to be the same. They won't always be the same. So the physical distance of the outside is also 4 pi. Questions on that? 2 special. So 2 squared is the same thing as 2 times 2. So this one just came out the same, happened to, but they won't always come out the same. Questions? Okay. All right, it says, what's the area of the sector? So instead of finding the area of the full circle, we're not filling in the full circle. We're just finding the area of a section of the circle. So we're just taking into consideration, okay, we know area of a full circle is pi r squared, right? Everyone? So then area of a section of the circle, aren't we just saying we want the section out of the full circle instead?
So you divide it by that.
So we do the section divided by the full circle, and then we're still finding the area, so it's still pi r squared. Right? Remember that? That's why this formula shouldn't be that hard to remember, is it's just like the area of a circle. You're just saying, I only want the area of this piece out of the full circle. We've talked about that a lot. Questions on that? Okay, so we want to fill in that highlighted region. So it's 60 out of how many? 360, right? 60 degrees out of 360. Are you guys internalizing this so that like you are making sense of why it makes sense so that you'll remember it in a week from now? So 60 over 360 times by pi, what's my radius? 6 centimeters squared. So let's just type it into our calculator. Remember, we multiply straight across. There's like a 1 under these. So I'm just going to do 60. Guys, how many times do I have to tell you we don't type pi into our calculator? Our answers are prettier in terms of pi. If you're a mathematician, you want your answer in terms of pi. So 60 times 6 squared. Hit enter. Divided by 360. You get what? So 6 pi is the area of the section of that circle with a radius of 6 centimeters. So we would say 6 pi and then square centimeters squared, because technically wasn't it 6 centimeters times 6 centimeters? Sorry, which is centimeters squared. Okay. Next problem. It says, is AB tangent to the circle? The radius of the circle is 9. So looking at this picture, we're going to determine if AB is tangent to the circle. So remember, if you drop a radius to a tangent line only touches the circle once. Hold on, I have to get this up. Okay. So is AB tangent to the circle? If you drop a radius to a tangent line only touches the circle once. If it's truly tangent, then your radius being dropped will create a 90-degree angle. But that's only if it's truly tangent. Now in the problem it says we're checking if it's tangent. If we're told it's tangent, we can put the 90 degrees. So we're not actually putting the 90 degrees because we don't know if it's tangent. We're checking. So the radius of the circle is 9. So isn't this distance 9? Isn't any radius 9? So will this full distance be 12? So let's check to see if this is a right triangle. If it is, it's tangent. That made a 90-degree angle right there. So we'll do 9 squared plus 6 squared is equal to our hypotenuse squared. If that's a true statement, it was truly tangent. 9 squared. Did it come out right? 9 squared plus 6 squared.
Where did you get the 9 again?
9, it says is in the instructions of radius.
Oh, it is right. No.
So 117 does not equal 144. Therefore, yeah, that's a triangle. It's not a right triangle. So we would say not tangent. That's not 90 degrees. Not tangent to the circle. Questions on that? Okay, looking at this, it says, solve for y, assume the lines that appear to be tangent are tangent. Tangent line touches the circle once. Isn't that a tangent line from here to here?
Yes.
Isn't this a tangent line touching the circle once from here to here?
Yes.
Yes. Isn't this a radius and a radius?
Yes.
Okay. If you drop a radius to a tangent line at the point of tangency, it creates a 90-degree angle. We're told to assume the lines which look to be tangent are tangent. So aren't those 90-degree angles, guys?
Yes.
So let's solve for y. Isn't this a four-sided figure?
Yeah.
The angles in a four-sided figure add up to be 360. So let's do 360 minus 45. Minus 90 minus 90. What would y be? 135 degrees. Questions? Okay. This one, solve for x. These are the easiest ones. If you can do back to secondary math, not even secondary math 1. Well, yeah, I guess it is secondary math 1. Pythagorean theorem, you can solve problems like this. Okay, you just got to be able to use your brain a little bit. So looking at the picture here, we have this line right here being dropped at a 90-degree angle, right? So don't we know for sure, only if we know that this is 90 degrees do we know that this and this are cut evenly, right? Okay, true. So this is 3, this is 3. Now we know this is x. If this radius is 5, can't I draw my own radius? Because by the definition of a radius, if you draw a radius on a circle anywhere, isn't it the same?
Yes.
So this is 5, guys. Draw your own line and make yourself a little right triangle. Okay, now let's solve for x, Pythagorean theorem. Hypotenuse is 5. So let's go ahead and set up a Pythagorean theorem. We have all the sides of the right triangle except for one. So we'll do x squared plus 3 squared is equal to the hypotenuse, which happens to be 5 squared. So we have x squared plus 9 is equal to 25. So we have x squared is equal to 16, right? Minusing 9. I should be able to go through this fast. We're kind of just zipping through this. X is equal to technically plus or minus 4, right? But in this problem, since this x is a length with just x, we would know we throw out the negative 4. So x is equal to 4. Questions? So I said to you, okay, so if x is 4, now I'm going to extend the line and say, well, it's y. What would you say? It's not that hard. It's 1, right? Isn't a radius drawn no matter what? 5. So if this piece is 4, will that piece be 1? Does everybody understand what I'm saying? This is 4, this must be 1. The radius, no matter where it's drawn, is 5, right? Ding, ding, 5. Okay, good. X is 4. Very good. Next problem. We're almost to the end here. What is x, y, and z? So you've got to know your angle measurements, okay? Remember, if you have a central angle, it starts at the center of the circle and opens up on an arc. A central angle equals its arc. I'm going to say that again. A central angle equals its arc. Now, if you have an inscribed angle, it's an angle formed on the circle, not in the center, opening up on an arc. So do you see how this is forming an angle? It did not start at the center of the circle. It started on the outside of the circle, right? Has to start on the outside of the circle. I should have said that. So it did, and it opens up on an arc. That's an inscribed angle. And we know an inscribed angle is half of the amount of its arc, right? Everybody? Central angles equal their arc. Inscribed angles are half the amount of their arc. This is an inscribed angle. A central angle starts at the center and opens up. Inscribed angle does not start at the center. It starts on the outside of the circle. So it does have to start on the outside of a circle. So let me show you what would not be an inscribed angle. Even though it didn't start at the center, did it start on the outside?
Yeah.
No. Started right, like off in the middle, but not in the middle. You know what I'm saying? That's not an inscribed angle. Okay. So an inscribed angle is half of the amount of its arc, or the arc is twice the inscribed angle. I'm going to erase that purple line. Okay, so we're not all confused. Let's start here. Okay, so we're finding x, y, z. We're just going to go around and see what we know. Isn't this from here to here a half circle, guys?
Yes.
Is this from around right here a half circle, though? No. Okay, so around here is a half circle. So if this is 100 degrees from here to here, what's y? 80 degrees. Questions on why that's 80 degrees? Okay, so y is 80 degrees. That is very true. Now, isn't that the arc from here to here? The arc that is being opened up on by this angle. Look, isn't that opened up on that arc, guys? Yes, so what is angle Z? 40. It's half of the amount of its arc, so it's 40 degrees. Very good. So we know Z is 40 degrees. Okay, now let's look. X. X is an inscribed angle, right, everyone? Isn't this an inscribed angle? And it's opening up on the arc from here to here. Does everybody see that? So if we knew this, then we could find X. So let's find that. Isn't a full circle 360?
Yes.
So 360, go. 360 minus 45 minus 80 minus 100 leaves us with 135 degrees. Thus, what's X? Yep, 67.5 degrees. You take your 135, which this angle's opening up on, divide it by 2. So we found X, Y, Z, guys. Questions? You might have to work your way around. Did you see how we just migrated around? And we couldn't necessarily find X right at the beginning, but it took us a minute to get it. Okay. Next one. What's A? What's B? Don't we have a bunch of inscribed angles here? Don't they start at the outside of the circle and open up?
Yes.
Okay, so I want to make a point here. I have been given, if you're given an inscribed angle, there's a good chance you're going to use it. Isn't this inscribed angle 120 opening up on the arc from here clear around to here?
Yes.
So when we take that arc is 120 times 2. Okay, so this is 240 degrees. And you tell me what's A.
100.
You take your 360, right? 360 minus 240 minus 20 is 100. Very good. So A is 100. So we found A. 100 degrees. Now let's find B. Isn't B an inscribed angle? Opening up on the arc from, looks like here to here, right? Yep, so that arc from here to here is 120. Therefore, B must be 60 degrees. Good. Okay, that's all we're going to do. Skip page 68. You're doing up to page 67. We don't have time to learn page 68. I thought we were going to actually learn it in one of the days before today. So you can really just cross it out. We are not going to get to it. Cross it out. We even learned it this year. And then do pages up to 67. Hey, then you know that practice test? Make sure you really do that. That's going to best prepare you way over the Sage packet. So after you're finished with the Sage packet, do that practice test I gave you yesterday.